All right, let's practice some log properties. Here in this first example, we're asked to expand this logarithmic expression. And we've got several things going on here. There's a product in the numerator. We've got some exponents. We also have a quotient overall. So all three log properties are going to come into play here. I'm going to start with the quotient. Remember that when you're dividing, we subtract exponents. And since logs are exponents, that means that I can rewrite this as log of 5x to the fourth, log base 7 of 5x to the fourth minus log base 7 of the square root of y cubed. I've also got here in this first expression, I have a product, 5 times x to the fourth. And whenever we are multiplying, we add exponents. And so I can break that up as log base 5 plus, I think I said log base 5, log base 7 of 5 plus log base 7 of x to the fourth. And then of course we still have minus log base 7 of the square root of y cubed. So I've applied the quotient property here in the first step, applied the product property here in the second step. I can also apply the power property. I've got an exponent here in this term, x to the fourth. I also have an exponent here on our last term, but I have a square root there, and we really need to rewrite that square root as an exponent before we apply the property. So remember that roots can be rewritten as fraction exponents, and so I'm going to rewrite this as y to the 3/2 power. And now in my last step, I'm going to take both of those exponents, the 4 and the 3/2, and move them to the front of the log. So my final answer would be log base 7 of 5 plus 4 times log base 7 of x minus 3/2 times log base 7 of y. Let's look at another example of expanding. Sorry about that. Here we go. We've got the natural log of the cube root of 5x squared divided by y to the fourth. So again, let's do that quotient property first. I'm going to rewrite this as the natural log of the cube root of 5x squared minus the natural log of y to the fourth. Now in this first term, I've got a product, 5 times x squared, but I also have the whole thing that's under a cube root. And so we really need to deal with that cube root first. First of all, I'm going to rewrite it as an exponent. And I'm going to put parentheses around 5x squared because that cube root, which now I'm writing as an exponent of 1/3, is for both the 5 and the x squared. And of course my next term is still going to stay the same, natural log of y to the fourth. So now for both of these terms I can actually apply the power property. I can take these exponents, the 1/3 and the 4, and move them to the front of their logs. 1/3 times the natural log of 5x squared minus 4 times natural log of y. So now my last term, it is as simplified as possible. This term is done. But here in my first term, I still have a product going on and I have another exponent. So let's deal with the product first. 1/3. And I'm going to separate the 5 and the x squared. But I'm going to put it all in parentheses with the 1/3 out in front because remember the 1/3 is still for both of those, both for the 5 and the x squared. And my last step will be to apply the power property one more time for that 2. So 1/3 times the natural log of 5 plus 2 times the natural log of x minus 4 times the natural log of y. And that would be our final answer. Now let's look at two examples that ask us to kind of work in the other direction. We have an expanded logarithmic expression, and we're being asked to condense it. In this first example, we've got some addition and some subtraction. I've also got some numbers being multiplied in the front of the logs, the 2 and the 1/2. So let's deal with those first. Do our power property first. If I have a number in front of the log, that means that I can rewrite it as an exponent. Like here, instead of 2 times log y, I'm going to rewrite that as log of y squared minus log of z, log base 3 of z to the 1/2 power. All right, next step. My first two logs here, they're being added, and remember that logs are exponents. Whenever we're adding exponents, what are we doing? Well, we're multiplying. So I can rewrite, and I'm going to go ahead and get this all in one log. We can rewrite that as x times y squared. Now I have minus z to the 1/2, and of course if you're subtracting exponents, that means that you must be dividing, and so we're going to divide by z to the 1/2. Now this would be an acceptable answer in this form, but it could also be rewritten as log base 3 x times y squared over, remember that 1/2 exponent, it means square root. And so instead of z to the 1/2 in the denominator, we could have square root of z. Let's look at one more example like this. Now in this example, we've got natural log of 5 divided by 3 minus 2 times the natural log of x plus 5 times the natural log of y divided by 3. And those divided by 3's there, sometimes it helps if you just rewrite that as a fraction being multiplied by the log. For example, instead of natural log divided by 3, I could rewrite this as 1/3 times the natural log of 5 minus 2 times the natural log of x plus 5/3 times the natural log of y. So now we're ready to start applying our properties, and I'm going to do the power property first. Each of my log terms here have a number in front, and so I'm going to rewrite all of those as exponents. Natural log of 5 to the 1/3 minus the natural log of x squared plus the natural log of y to the 5/3 power. Now we're ready to apply our product and quotient properties and combine all this together into one log expression. Natural log, now here I have 5 to the 1/3 minus the natural log of x squared. If I'm subtracting exponents, that means we must be dividing. And so I'm going to rewrite this as division. 5 to the 1/3 is on top, x squared goes on bottom. And then with my last term, my last log term, it's being added. And if you're adding exponents, that means you must be multiplying. So I'm going to multiply this on the top times y to the 5/3 power. And then let's go ahead and do rewrite those fraction exponents as roots. And since, well, I'll go ahead and do them separate in the first step. I could rewrite this as the cube root of 5 times the cube root of y to the 5th, remembering that fraction exponents can be rewritten as roots over x squared. But since both of those terms on top are under a cube root, it would also be correct to combine them under the same cube root as 5y to the 5th, and then of course still over x squared. And so that would be the condensed version of that log expression.